So this is my fourth video on special theory of relativity. So in previous video I talked about the Einstein postulates. So in this video I am going to derive the Lorentz transformation equations. So what are basically the transformation equations? So if you have two frames S and S prime, and S prime is moving with respect to this frame with some constant velocity. So if you have measurements in this frame, in S frame, so you can shift into S prime and also vice versa. So these are basically the Galilean transformation equations which I derived in the second video. So also we know these Galilean transformations equations are not general. So we discussed this in the previous video. So now we are going to derive or in other words we are going to modify these equations so such that they work well at the higher velocities. So the assumption which we are taking here is that the speed of light in vacuum is c and it is constant for all inertial frames. So in each frame we will find this speed c. And another thing is that these transformation equations work well in the low velocity regime. So we want our new transformation equations such that for low velocity regions, so our new transformation equations should reduce to this form. Here are some other facts. So transformation equations are linear. So our transformation equations should be linear and there should be one-to-one correspondings. For example, if this x prime is equal to x squared, so look here, so here if I put plus 2 or minus 2, so it is equivalent because I am taking square. So it means that the event that is happening at x prime at one particular position, so it will be happening in S frame at two positions, so which is against. For example, if there is an event at one particular location in one frame, so this event should be at one particular location in another frame, so it cannot happen at two different frames simultaneously. So therefore this is not true. So we should have this type of relations, so they should be linear and there should be one-to-one correspondence. Also if it is like x squared, so here we will have the acceleration. So that is, if you differentiate this expression, so you get this acceleration. So look here, if the acceleration in this frame is 0, so in S frame this acceleration does not become equal to 0, so that is not possible. So acceleration in both the frames should be equal to 0. So taking our these assumptions that the c is constant, the transformation equations are linear and there is one-to-one relation, so I take this form that the x prime is, and here look at the same equation that are in the Galilean transformation, and now there is a constant multiplied by this constant a. Since the motion is along x-axis, so there will be no change along y-axis, so y prime should be equal to y, z prime should be equal to z, but time should be equal. Time is a function of both x and time. So if in one frame if you are in one frame, you see that the time is separate and space is separate, but if you go to another frame, so both will be intermixed. So now this is our form for new transformation equations, and all we have to do is to find the value of this a, this d, this f. So I'm going to find these constant, and once we have found the constants, we will get our transformation equations. So now here assume that we have this frame S and this is S prime which is moving with speed v with respect to this S prime, and it is such that at time t is equal to 0, these two frames overlap. Means that if this frame is moving in this direction, so in the past it would have been here, here, here. So we choose time t is equal to 0, that moment at which this O and O prime overlap each other, or they are at the same location. So that is our assumption. So now if there is an event means that, let's say at time t is equal to 0, a flash of light is emitted and it travels in the x direction, in the y direction and in the z direction. So a flash of light is emitted at time t is equal to 0 when this O prime and O are at the same location. So how can I write the coordinates? So in S prime after some time t, so let's say this will reach here. So now this particular point will have certain coordinates. You should remember that this event is happening along the x direction. Here it looks like it is in plane, so that is not true. I should have drawn it here, but you should assume that this beam of light is on the x-axis. So the event 1, for this event that the light reaches at this point P, can be written as x coordinate y is equal to 0, because this is emitted along the x direction only. Y is equal to 0, z is equal to 0, and a particular time t. So now for this point I can, in fact this is this point, but I am showing it here for the simplicity only, for the simplicity of the geometry. And similarly for this particular point in S prime frame, I can write x prime, y prime, z prime should be 0, and t prime. So now these are the coordinates for the first event. And now we will use this postulate that the speed of light is constant. So since you know that how much distance is traveled, or in other words how much this x is, because at time t is equal to 0 the light was at origin, and now at time t it has covered some distance. So if it is moving with speed c, and in time t, so it will cover this distance, x is equal to ct. Okay, and now I'm using this transformation equation here. So x prime is equal to a x minus vt. So if I put the value of x here, which is ct, so this gives me ct minus vt. And also I can take this t out, so this gives me a times t c minus v. And now we will use the second postulate that the speed of light is constant in all frame. So this x prime would be equal to c times t prime, because the speed of light in S prime frame is also c, and the time passed in S prime frame is t. So this gives me c t prime is equal to a times t c minus v. So this is our equation. Now I will use this equation here. So this gives me t prime is equal to d, which is a constant, and x coordinate plus f and t. So t as it is, d as it is. So in the place of x I can put ct plus ft. So from this equation I can find the value of t, which is basically at by c minus v. So here I am putting the value of t. So this gives me a times t c minus v divided by c is equal to this portion, which is what, dct plus ft. So you see here there is t. So this t will be taken common and it will cancel out. So we will left by a by c minus v is equal to dc plus f. So if I multiply this c on the other side, so this gives me ac minus av and dc squared plus fc. So dc squared plus fc is equal to ac minus v. So this is basically minus here. So this is ac minus v, and this is our first equation. Now we take the second event here. So the second event is what, that the light is emitted in the negative x direction at time t is equal to 0. Light is originated from origin, so it spread in all the direction. So now we are taking the negative direction. So this, for the second I can write that x coordinate, y coordinate is equal to 0, z coordinate is equal to in time. And similarly for S prime frame we get x prime and t prime. Again our transformation equation is x prime is equal to a x minus vt. So I can put the value of x prime here. So of course the light is traveling in the negative x direction, so it will travel with speed minus c, and the time that will pass will be minus ct prime. So this is from the second postulate, the speed of light is constant in all inertial frames. So s is equal to ct, and this is equal to a as it is, and in S frame it will give us minus c into t. So this t is the distance covered in the S frame, minus vt as it is. So this gives me minus ct prime is equal to, and you can take this t out, so minus a times t and c plus v. So this gives me the value of time. So this gives me a t by c plus v. Also, we know from our transformation equation that we have taken this form, we have assumed this form. So t prime is equal to dx by ft. So I can put the value of t prime here from this equation. So this gives me a t by c, c plus v, and here d as it is, and in the place of x I can put the x is equal to minus ct, because this is the distance covered in the negative direction in S frame, plus ft as it is, and you can simplify it. So this will give you minus tc squared plus fc is equal to a c plus v. So this is my second equation. So for now we assume the third event, and third event is that the light travels along the y direction. So at time t is equal to 0 it is originated from the origin, and then at time t is equal to 2 it reaches at a particular point along y axis. So now for this event I can write x is equal to 0 because this event is happening along the y direction only, and y will be ct because the distance covered will be ct, z is equal to 0 and time coordinate is t. And similarly in x prime will be 0, y prime we don't know, and this z prime will be equal to 0 and t prime as t prime. So using our transformation equation, this is our transformation equation that x prime is equal to a x minus vt. So here x is 0, see, so we can put it, so this gives me x prime is equal to minus a vt, and y prime is ct. Obviously the distance covered in any frame by light will be c times t, using the second postulate, and z is equal to 0 and t prime will be equal to ft, because t prime we know, so this is basically t prime, so t prime is equal to dx, so x is 0, so this only gives us ft, so t prime is equal to ft. So for this third event I have obtained these relations, and now this is, let's say, our y direction. So how much this distance is? So this distance will be d, so if I can take its square, d squared, I am constructing a quantity which is the square root of the distance. And you know from your algebra that this distance, the distance in any coordinate is x square plus y square plus z square. That if you have a point in space p x y z, so the distance from the origin is given by x square plus y square plus z square square root, and therefore the distance squared will be equal to x prime square, y prime square and z prime square in the x prime frame. Also the distance is basically c times t prime, so I can put c square t prime squared here is equal to value of x prime, y prime and z prime from here. So this gives me a square v square t square plus c square t square plus 0 because z is 0, and I can simplify this relation. I can also put the value of t prime squared here, which is ft. So this gives me a square v square plus c square f square. So this is my third equation. So I have written all these three equations here. So this is my first equation, second equation and third equation. Here I have three constant a, f and d. So I need to find the values of these three constant, and I have three equations, so I can do this. So if I use this operation, the first equation plus second equation, so if I use this operation, you see here, so this quantity will cancel out. Here we will have 2 times fc, so 2 times fc, and also ac minus av plus ac plus av. So ac, so av will get cancel out with av, so I will get 2ac. So this gives me f time is equal to a, because c gets cancelled out and 2 gets cancelled out, so f is equal to a. So I have found the value of f which is equal to other constant, so it means I have only 2 independent constant, that is a and d. So if I put the value of f is equal to a in this third equation, so this gives me a square v square as it is, c squared as it is, and then c squared as it is, and on the place of f square I can put a squared. So so simplifying this, so I can take this on the, I can rearrange this. So this gives me a square c square by c square minus v square. So here if I take c squared common here, so it will get cancel out here. So I will get 1 over 1 minus v squared by c square, and taking the square root, so this gives me a is equal to 1 over square root 1 minus v squared c squared. So we have found the value of a, which is of course equal to f. Okay, now to find the value of d, so I can use any equations first or second, because I know the value of f and I know the value of a, so I can easily find the value of d. So I can use any only equation. So I am using the first equation, that was basically the d squared c squared plus fc is equal to a c minus v. So if I put the value of f and a, so I can get the value of d. So that is also, if I put the value of f here, which is a, so this gives me ac, and on the other side I have ac, so ac will get cancelled out here, so I will left with dc squared is equal to minus av, and from here I can get d is equal to minus av divided by c squared. So here I will get d is equal to minus a v by c squared. So I can put the value of this a, which is basically 1 over 1 minus v squared by c squared. So this gives me d is equal to minus v by c squared divided by 1 minus v squared by c squared. So we have found all the values. We have found the value of a, d and f. So putting back into so here so this was basically our assumptions, the equations that we were so now I have found the value of a, f and d, so I am putting it here. So this gives me, since x was this, so I can put the value of a here, which is 1 over 1 minus v squared by c squared, so I put it here, and x minus vt. So now this is our expression for the x coordinate, and y as it is, z as it is, and on the place of time dx plus ft, so I can put the value of d and f, since f is equal to a and the value of d, so this the value of d contains 1 minus v squared by c squared, and this is also the denominator of a, so this gives me minus v by c squared 1 minus v squared by c squared, the value of d, plus the value of f, which is basically a, 1 minus v squared by c squared. So this gives me t minus v by c squared x, 1 minus v squared by c squared. So I can write this in simplified form. So x prime is equal to x minus t, and this entire factor 1 over this factor is known as gamma. Okay, and y prime is equal to y prime, z prime is equal to z prime, and here I again have this 1 over this factor, so this is equal to t minus v squared by x. So now these are our transformation equations. So if we know the value of x and t in the s frame, so we can find the value in the prime frame, provided that we know this v coordinate, the speed of frame. And also, you know from principle of relativity that there is no preferred inertial frame, so all inertial frames are alike. So therefore, if so here in my assumption I have taken x prime moving in this direction with speed v, and s was at rest. So according to principle of relativity, I can call this s prime frame at rest and this s frame moving in the speed minus v. So this comes from the principle of relativity that there is no preferred inertial frame. So therefore, now this x prime is my rest frame and this s is motion, the frame which is in motion. So I can shift my values from, prime to unprime. So all you have to do is to replace the prime by unprime and replace the v by minus v. So you can shift here. So look here, if I replace this x prime by x, so this gives me x is equal to gamma, and here I will get the x prime plus vt. So that is all. So all you have to do is to replace the prime coordinate by unprime and v by minus v. So you get these transformation equations. So these are the reverse transformation equations. So if you know the value in the frame which is in motion, so you can shift into the rest frame, or if you know the value in the x frame in the rest frame, so you can shift your value in the frame which is in motion. So that was all for this video. And one thing more, look here, I said that the transformation equations should be such that they should reduce to the Galilean transformation equation when the velocity is small. Okay, so if this v is very less than c, so I can expand this expression by binomial theorem. So this will give me 1 minus v squared by c squared power minus 1 by 2. So if you expand this, so this gives me 1 plus v squared by c squared. So this term goes to 0 because this v is much smaller than this c, so we will get 1. So the idea is that in the limit when this v is very less than c, so this gamma approaches to 1, and therefore we will get the Galilean transformation back. So in that case here what we will have x minus vt. So that are the basically the Galilean transformation equations. So that is all for this video.